Okay, so this video is simplifying expressions or combining like terms. So you're going to hear me throw this phrase around, like terms or combining like terms. And once we get to a few examples, I'll explain what exactly that means. So we have some expressions here. And if we look at the first one, we have 4x plus 3x. And if you notice that after the 4 we have an x, and after the 3 we have an x. So the x's are the same, so it's kind of like a matching game. These are what we call like terms. So since those x's are the same, what I can do is take those numbers in front and add them together. 4 plus 3 will give me 7, and then just write down that common variable, the x. So this is what we call combining like terms. They're like terms because they have that x in common. Likewise, for the second one here, I have 6x plus 4x. The x's are in common. I can add the 6 and the 4. That gives me a 10 and the variable x. Next one here, the x's are in common. So take the 7, add the 2. That gives me a 9 with the common variable x. Some more examples here. And if we look at the first one, you notice that this term looks good, but we haven't seen a term that looks like this. Well, there's no real number in front of the x. But when that happens, we're always going to imagine there's like an invisible 1 there. So just treat that as a 1. So the x's are common. There's x's in both. So I can take those numbers in front and put them together. So 3 plus 1 will give me a 4x. The second one here, I have an A and an A. There's no number in front of this guy right here, but we'll treat that as an invisible 1. 2 plus 1 will give me a 3A. And the last one here, I have the A's in common. They kind of look like 9s, but they're A's. Then there's an invisible 1 there. 1 plus 4 will give me 5, and that common variable A. So these are some examples of when we're dealing with subtraction or even negative numbers, but it still works the same way. So we have the variable b for the first example. I can add the numbers in front together. So 6 and a negative 2, or 6 minus 2, that gives me a 4 with that common variable b. The next one here, 4x minus x, there's an invisible 1 in front. So we have 4 and negative 1. 4 minus 1 will give me 3 with the common variable x. The next one here, again, x's are in common. Negative 3 plus the 5 will give me a 2 with the common variable x. And the last one on the slide here, the x's are in common, so I can combine the negative 2 and the negative 3, add or subtract those together, however you like to think about it. Negative 2 minus 3 will give me a negative 5 and the common variable x. So I'd like to give some non-examples, some examples that cannot be combined while we're at it. So if you notice the first expression here, and if we look at the variables, I have an x and an x squared. So before we talked about ones that were just x and x, or a and a, they can be b and b, or y and y. They have to be exactly the same. You kind of want to be picky about these. They have to be exactly the same for them to be like terms and for them to combine. This one can't combine because one's an x squared. Even if it's just a exponent, they are different. You cannot combine them together. So we'll just leave that as negative 3x plus 5x squared. It's already as simplified as it can be. With the second one, b and an x, they're different. They're not the same. So 2b minus 5x, we'll leave that one as well. And the last one, b plus a, again, the b and the a are different, so I'm just going to leave that as b plus a. So this slide, we're going to look at some examples where, and maybe not the first two, but the last two, where you can combine some of them, but not all of them. But I'll get ahead of ourselves. And the first one here, we have a 3x plus 5x plus a 2x. Now you notice that all three terms, remember terms are the ones that's separated by the addition sign, all three of them have an x. So I can combine all three numbers in front. So 3 plus 5 plus 2 will give me a 10, and the common variable x. The second one, looking at all three terms, they all have x's in them. I have a -2, a 5, and a negative. Remember, there's an invisible 1 there. So -2 plus 5 will give me a 3. 3 minus 1 gives me 2. So that's a 2x. The third one, if we look at the terms, I have an x squared, an x, and an x. So I can only combine the ones that are the same, so I can only combine those two. So the one out front here, we will just rewrite 2x squared. And then when I can combine 2x and a minus x, so minus 1x, that's going to give me just a positive x. You can kind of think of it as a 1x, but you don't really need that 1. There's that invisible 1 there that you don't need to write. The next one, we have an x squared, and a b, so I can combine these two together. So 4x squared minus 2x squared, that gives me a 2x squared. And then we'll just add that b. If you can't combine a term, just write it on the end. We're not worrying about standard form quite yet. So the last slide of this video, so just a little more complicated problems. So if you look at this one here, I have a b. I have another b here, but I also have an x squared and a normal x. So the big question here is, which ones can I combine? So you can only combine the ones that are like. So the only ones I can on this one are 3b and that minus b. So when I combine those together, 3b minus b, or minus a 1b, that gives me 2b. Can I combine the x squared and the x? No, the answer is no. So I'm just going to rewrite the 2x squared and rewrite the plus 3x. Now we won't worry about standard form with these problems. That'll be a later topic, so we'll just leave that as is for now. And the last one. So I have an x squared, and x to the third. Can I simplify that? They're all different, aren't they? One's an x squared, one's an x to the third. So that is already simplified as it can be. And we will just leave that as